Okay, guys, please. Okay, guys, first of all, can we start now? Okay. First of all, I am going to talk about combinations of the resistor. There are two basic combinations that we usually deal with. The first one is series combination, and the other one is parallel. What is difference between them that we need to know? In series, if you have resistances like I have this resistance R1, I connected these two resistors in this way with the battery that the current provided by the battery will have only one path. What is the meaning of one path? If this is a positive terminal, this is negative terminal, current start from positive terminal, the same current that is provided by the battery I, voltage is V, will pass through resistance R1 and also will pass through resistance R2. So what I am repeating here, series combination is a combination in which current have one path. Current has one path to flow. Okay? So this is the basic definition. I have one path. This I am writing not me, I for the current. Okay, and the parallel combination is what? Parallel combination is in which resistances, let's say R1 and R2 are connected terminal to terminal. For example, this is terminal A of both of the resistances and this is terminal B. Now, if you apply the battery at terminal A and terminal B having a voltage V, what will happen? The current that is provided by the battery, let's say it is I, but when it will reach at the terminal A, it will have two different paths to flow. It will change to I1 and I2. But when it reach at B, it will again combine and it will become I. So first thing is that the total current I is splitted into I1 and I2. Whatever the value of I is, for example, it is 5 ampere. So I2 will be, let's say, 2.5 and I3 will be 2.5, but the total will be 5. Maybe 2 plus 3, maybe 1 plus 4, depending upon the resistances. So here I will write the definition that whenever it is a parallel combination, so you will have the current I will have many different paths, will have different paths. Okay, this is the definition of the parallel combination. So current will have different paths. This is first and foremost thing that we need to remember. In series, same current will flow through the resistances. In parallel, current will be divided. Okay. Number two, the voltage. In series, voltage distributes. What happened? Voltage distributes. For example, if the total voltage provided by the battery is V, so voltage will distribute to V1 and V2. But when you add V1 and V2, you will get the same. So voltage across R1, let's say it would be V1 from here to here, it would be V1. Let me name it terminal A to B. And for R2, terminal is B to C. So voltage may be V2. So here you have to remember that for series combination, voltage is distributed. In parallel combination, current is distributed, but voltage remains same. V remains same across the terminals A and B. What is the meaning of same? Same as battery. So battery is providing terminal potential VAB. So you will have VAB current, VAB voltage across this. So total voltage from A to B is equal to the voltage of the battery, that is V or VAB, whatever you will say. Because you can see the terminals here are A and B. So voltage from the battery is also having the same terminals and resistance also have the same terminal. Now this is Second thing, and third and last thing, if you want equivalent resistance, what is equivalent resistance? It is denoted by Req. Equivalent resistance mean sum of all the resistances used in a circuit. So if you add all of the resistances in series combination, your answer will become sum of all added up. So equivalent resistance in series combination will be like just adding up the amount of resistances you have. If you have two resistances, you will say R1 plus R2 is equal to equivalent resistance. But if it is a parallel combination, then you will have the value of the resistance less than the least resistor. For example, if you are having in series 2 ohm and 4 ohm resistances, your total resistance will be 6 ohm. But if you have 2 ohm and 4 ohm in parallel, your total resistance will be less than 2. In series, your resistance will be more than 4. In parallel, it will be less than the least. So, how you use the formula? You use 1 over R equivalent is equal to 1 over R1 plus 1 over R2. But for two resistances, we can change this formula. For more than two, you just keep on doing 1 over R3, 1 over R3, just add them up. But for two resistances, we can also write it like R equivalent is equal to R1 times R2 over R1 plus R2. So this is only for the two resistances when you have two resistances connected in parallel. So here I would like to add one very, very important thing, that whenever we are asked in series combination, so you will see R equivalent will be greater than R1 plus R2. This is very, very important result. R equivalent will give you answer R1 plus R2 or equal to R1 plus R2. But in parallel, R equivalent will be less than the R1 and also less than R2. So this is something that you have to remember, that it will be lesser than R1 and it will be lesser than R2. Let us go to practice how this works. So first thing first, you have two resistances, 10 ohm and 15 ohm. What is the smallest value? You know the smallest value is because of the parallel combination. And what is the largest? It is because of series combination. So when you have largest value, it means you will connect them into series. So what is their resistance value? You can just simply say R equivalent is equal to R1 plus R2, and you can say R equivalent is equal to 25 ohm. And this is, you can say, this answer 25 ohm is more than 15 and 10. Just add it up. But here in the smallest value, whatever you will get, the smallest value here is for parallel combination, as I told you. So when you are using two resistances in parallel, I told you, you can directly say R equivalent is 10 times 15 over 10 plus 15. So this will be 150 over 25, and your answer is 6 ohm. And you can see this answer is lesser than the smaller resistance. What was the smaller resistance? Lesser than smaller resistance, that was 10. The answer is less than 10. So this result you have to remember. If I ask you the question, if 10 ohm and 15 ohm are two resistances and you want to uh, get the range of the answer, so your answer range from R equivalent will range from where? It will be greater than 6 ohm and it will be less than 25 ohm. So if I can give you an option, there are two resistances and what will be their possible resistance. So I am not giving you series parallel here. I'm just saying what might be the possible resistor, equivalent resistor. With these two, you can get, you can say, from 6 to 25. Not more than 25 possible, not less than 6 is possible. So this is what we can do with the equivalent resistances. Okay, now the next one, if you see, we have series parallel and light bulbs and in also parallel. So first of all, when you are going to see uh, figure number one, this one, in this figure, what is the combination? This is series combination. When this is series combination, what is the voltage you have? 12 volt. Voltage applied is 12 volt. Can you tell me the resistance R equivalent will be more or less? It is more in the series. We just studied in previous slide that R equivalent is more. When resistance is more, current will be current will be less. So more resistance, less current. This is less current mean how much will be the brightness automatically when current is less. You will say P is equal to I squared R. So I is squared here. I squared R. So it shows that less power because I is less more. So R is more, I know, but I has a square. So less with a square will have more impact. So you can say its power is utilized less, so it will be lesser bright, lesser bright in series. Yes, I am going to repeat. I said when we did talk about in series combination, our resistance is more, resistance more mean current less. When current less, according to the rule, P is equal to, let me change the rule to get you more understanding. P is equal to IV. When you use this relation, what does it mean? This is less, but voltage is same for both series and parallel, right? Voltage is 12 volt for both series and parallel. So voltage is same, current is less, so power output is less. So lesser power output mean lesser brightness. But for parallel, what will happen? For parallel, you know R equivalent is less, current is more. I'm talking about as compared to the series combination. So more current using P is equal to IV. The current is more here, voltage is same. So automatically more power consumed. So more power means you will have more brightness. More power, more brighter will be these. I am comparing both of these lights. Which configuration produce more light? So part A says parallel will have more bright light as compared to series. Okay, which way you prefer? We prefer parallel also. Why we prefer parallel? We prefer parallel because if one of the light bulb is damaged or burn out, so the other will continue light up. So parallel is better. We use our home appliances, we use our uh, vehicles, cars, they use the parallel combination of the lights. So in this way you can see if one of them is not working, other will continue to work, and if one is burned out, still other can continue to work out. Okay, this one is one thing. Now let us move to very important application that is called numerical problem. So here we have a combination parallel. I just draw here figure parallel. I didn't draw the series I will show you in the next slide. So if we are using in parallel combination, the battery voltage is given 24 volt. So what is the current through each resistor? So here, if you remember, I told you earlier on, the first thing first is we will find equivalent resistance. So I will tell you the step one always for the series and parallel combination is equivalent resistance. So step one, I am going to find R equivalent. Ibrahim, R equivalent in the parallel can be found by the 1 over R equivalent is equal to 1 over R1 plus 1 over R2. But for two resistances, it's easy because we can just directly do it, multiply at the top, add at the bottom. So here R equivalent, what is the amount of resistances here? Here resistances are 100 ohm, equal amount of resistances. So it will be 100 times 100 divided by 100 plus 100. So this answer will be 10,000 over 200. 10,000 over 200 maybe 500 or 50. It's parallel. I think it will be 50. Can you please check the calculator? So it will be 5. Yes. Can you please check? It's 50. 50 ohm. So one thing is also remember is if resistances are same in the amount, so when you use them in parallel, their resistance equally distribute becomes half. If it is 100, so in equivalent resistance it will become half. If they are same, I'm talking about. Okay, now first step I did it is R equivalent we found. What is second step? Second step is to find the amount of current. Which current I am talking about? I am not following the question. I am following these steps. Whenever you are asked to do, first step is to do R equivalent. Second step is to do total current provided by the battery. What is the amount of current provided by the battery is I. And I current can be found by Ohm's law. You know that what is I equal to? You know Ohm law says V is equal to IR. So Ohm law is V is equal to IR. So I is equal to what? Here I is equal to V over R. So here I will say I is equal to voltage provided by the battery over R equivalent. Don't use R1 and R2. R equivalent you will find. You already found it's 50. So voltage is how much? You have voltage 50 ohm and R equivalent is sorry, my mistake. Voltage is 24 volt and R equivalent is 50. So 24 over 50. Can you please give me the answer? 0.48. So total current through the provided by the battery 0.48 ampere. And if you want to milliampere, you will multiply it by 1000. So when you multiply it by 1000, what's the answer? 480 milliampere. Yes. So you can write it ampere or milli, it's up to you. Okay, now I'm coming back to the question. We know R equivalent. I just give you the idea how to find in parallel. We know the total current. Now we will go to the branch current I1 and I2. There are many ways. In parallel, same resistances, total current divided into two equal parts. Because I told you in the previous slide what is I in parallel combination. Here I try to show that I is equal to this one. I is equal to I1 plus I2. And if resistance is same, we can simply guess that it will be half from R1, half from R2. So it means 0.24 ampere, 0.24 ampere. But this is, I'm just telling you when resistances are same and you can divide them equally in parallel combination you can do it. But if resistances are not same, then you can use the ratio method also, and also you can use the other way. So here I1 is equal to how much? Use the Ohm law here, Yad. Use the Ohm law. I1 is equal to V over R1. Why? Because in parallel voltage remain same, and I2 is equal to V over R2, and V is how much? 24 over 100 and 24 over 100. I told you earlier on, if these are same in resistances, your answer will be divided equally. So I1 and I2 is equally divided to 240 ampere and 240 milliampere and 240 milliampere. So you can say if R1 is equal to R2, so I1 will be equal to I2, but total current I will be I1 plus I2. This is something you have to remember. If I'm just talking about parallel here, series, I'm now going to the next page. So here you remember three steps which I told you. But fourth thing, if they ask you for the voltage, what is voltage? What is voltage here? If they ask you voltage across the branches, voltage in parallel I'm talking about. Across branches is same. That's why I wrote I1 is V over R1, I2 is V over R2. But I told you logically we can directly say I1 is equal to I2, 0.48 becomes 0.24, 0.24. Okay, next one. Now if there is a series combination in part B, for example, you have the same resistances. This is R1, 100. This is R2, 100. The steps will followed will be the same. So this is 24 volt. This is 100 ohm. This is 100 ohm. The first thing first, I will go for the step 1. What was step 1? R equivalent. So what is R equivalent? R equivalent, you know that this is R1 plus R2, 100 plus 100, that is 200 ohm. Okay, this is first thing we found. Now the second step I told you is the total current. Step 2 is the total current. Total current passing through the circuit starts from the battery here, and you know it's the same amount of current passing through the resistances. It is series. So I will be also I1 and also I2. We will not say it I1 and I2 by the way, because it's the same current provided by the battery. So same current provided by the battery, I will say I is equal to V over R equivalent. So what was the V? V, you know that it is 24 volt, R equivalent is 200. So I is equal to 0.12 ampere, or you can say 120 milliampere. Okay, now how much is the current through R1? Same through same through R1 and R2. Now step 3. Now I need potential. Yes, potential here is divided equally. So I am going to find, this is not part of the question to find potential, but I am doing it because I can give you in the questions. So if you ask for potential, so you know that V is equally divided because same resistances. So 24 volt will change into 1212. Here it will be changes to 1212. But for example, if it is to find, so I will do V is equal to I1 R equivalent, V2 is equal to I2 R equivalent, but I1 I2 is the same. So I will write 0.12 times 200. What was, sorry, my mistake. This is not R equivalent here. Here you will use R only. Because we have current same, so I can write it I into R1 and I into R2 because I is same. So we don't need to write I1 and I2. So here IR1, V1 and V2 is IR2. So V1 is equal to I is 0.12 times 100. So it is 12 volt V1 and same amount of V2. 2 times 100. So V2 is 12. So here it is. We are done with everything in the circuit if the circuit is simple. But if circuit is a little bit different than this one, like this. Now you have series and parallel same. So we will go stepwise for the equivalent. Step 1 will remain same, R equivalent. But for R equivalent, what you will do here? For R equivalent, you will do stepwise. First, do equivalent for the parallel. So, what is parallel? Parallel is BC. So, I can say I am going to find RBC first. I have to find R equivalent, but I am going to find RBC first. Resistance across terminal BC. What is resistance across terminal BC? It is a parallel combination. What I will do? I will multiply and add. Numerator will be multiplied and denominator will be add. So RBC, because it is parallel, 500 times 700 divided by 500 plus 700. Yeah, the same thing. 1 over R equivalent is equal to 1 over 500, 1 over 700. Answer will be the same. Okay. But at the end, you have to flip if you use that one because that was 1 over R equivalent. So here, RBC is equal to 350,000 if I am not wrong. And this is 1,200. Zero zeros are cancelled. Please check it out if I am not wrong. Just give me in the fraction. No, give me fraction. Hmm? 800. Yes. 875 over 3 ohm is this. Now this circuit is changed. What happened to the circuit? This one from B to C is now changed into 875 over 3 ohm. So the new circuit now changes to this one. This is A to B. This is A. This is B. And here is C. So this one was how much? 400. This one is how much? 875 over 3. So now this is when you use this is a series now. So I can say equivalent resistance now it is total will be just added up 400 plus 875 over 3. What's the answer, please? Over 3 ohms. Okay. Now this is R equivalent. So when this is R equivalent, I need to find the total current. How I will find? Step 2 is total current. So if I need to find total amount of current, what I need to do? For total amount of current, you need to check the circuit now. This is your circuit. This is the circuit. In this one, you have 12-volt battery, and this is the R equivalent. So total current is I that is passing through this. I is equal to V over R. So I will use I is equal to 12 divided by 2075 over 3. Can you give me the current, please? 36 over 2075. Now give me rounded answer, please. 0.017 ampere. That will be 17 milliampere. Okay. Now I found the total current. But the problem is, this question is saying how much current is drawn. I agree. Yes, this current is saying how much total current. Until now, I am done with this example. But, but we got this current total I. But this question cannot stop at this point. This question may ask you what is the current I1 and current I2. If you look at the figure, I1 from 500 ohm, I2 from 700 ohm. But why it is not saying current through 400? It's the I. Already we found 17 milliampere from 400 because the 400 is attached to the same terminal with the battery. So this is 400. What is amount of current through 400 is? Amount of current through 400 is 17 milliampere. About 500 and 700, we need to know the voltage first. So for voltage, I will go to this figure. This figure. I will go to this second figure to know the potential across VAB and VBC. So first thing first, I am going to find VAB and VBC. What is VAB? VAB is across 400 and VBC is across 875 over 3. Why? Because in parallel circuit we combine into 875 over 3. The above figure you can see 875 over 3 ohm, this one. So VAB. So I am redrawing this figure just to have a quick look. So VAB is this. This is 400 400 ohm. This is VAB. This is VAB, A terminal, B terminal, and VBC is across 875 ohm over 3. This is VBC. Now, can you tell me total voltage was 12 volt? How can we find separately? We have the same rule. VAB is equal to what? VAB is equal to I R1. That is how much? I was 0.017 times 400. Can you tell me please? No. How 68? 6.8 is logical, not 68. 6.8 volt VAB. Now go to VBC. VBC is equal to I R BC. But the problem is we don't have current here. So what can I do? If VAB you know, what will be the VBC? I can't use this one. I cannot use because I don't know the amount of current here. Because this circuit is actually parallel. No, the total current we cannot combine it. This one cannot be combined here because I1 and I2 we need to know or VBC. So better way is if we know VAB to find VBC mean subtract from the total voltage. So VBC better way is the better way is you will say total voltage is minus total voltage minus VAB is equal to VBC. So 12 minus 6.8, how much is it? 5 point VBC is 5.2 volts. Okay, now we have VBC. Now, if you have VBC, now you can find I1 and I2. So, to find I1, what you will do? I1 is through 500 ohm. If you look at the figure down, what is I1 through 500? So, you have I1, Ohm's law is VBC over 500. What is VBC? 5.2 over 500. Can you give me the answer, please? 0.0110. Okay. So in milliamps, it will be 10 milliamp if you multiply by 1000. Okay. Now I2 is equal to VBC over 700. So I2 is equal to 5.2 over 700. How much is it? 0.007. Please check it out. 7.4 times 10 to the power of negative. Okay, so milliampere is 7.4. So approximately 7 milliampere. We use VBC twice. Yeah, okay, because VBC is the same for them. Now tell me, I1 is 10 milliampere, I2 7 milliampere. What was total? 17 milliampere. So now it is also checked that the total current is distributed into I1 and I2. Now here you have three electric light bulb. So the circuit shown is the identical bulbs. Identical bulb in parallel at this one. Can you tell me what is the resistance here in this circuit? This resistance AB is less than C. Why? Because it is parallel and RC is just connected as in series. So RAB is less than RC. Okay? RAB is less than RC. When we talk about the total amount of current passing through is I. How much current will pass through RC? I current, that is total I current through RC more than I1 and I2. I is more than I1 and I2. When I is more than I1 and I2, what does it mean? It will be more brighter. So RC, bulb C is brighter. Bulb C is brighter than B and A. But what about B and A? They are having equal resistance. So they will be equally bright. Bulb C is brighter than bulb B and C, which are equally bright. It's written. Look here. In the first line, it says the circuit in figure has three identical light bulbs. Mean they have same resistance. Identical light bulb mean same resistance. Can you just give me a second, please? Okay, thank you, sir. So nice of you. Okay, okay. I am with them. But no, just 10 minutes more. Only 10. Yeah, then I will leave. Yeah, it's okay. I just need 10 minutes. Okay. 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 Thank you, sir. Bye bye. Bye bye. He's saying just be with them. Stay with them? Yeah. He's saying you stay with them. Okay. Now, what thing they are saying equally identical but between same resistance. So when current provided by the battery is I, it is more. When it will become I1 and I2 in branches, it will be less because I1 plus I2 is I. So RC will have more current as compared to RA and RB. So that's why it will be this one. Now they are saying switch S is open. Where is switch S? This one is switch S. This one. If it is open, it means now your circuit is like this. Please look at the circuit. This is C and then it is series with bulb B. This is bulb B, this is bulb C, and this is the battery. Now, first of all, don't talk equal values. Talk about the current here. Will the current be more or less? No, from B and C it will be same, but I'm comparing with the previous circuit. In the previous circuit, current was more, total current was more. Why? Because this parallel combination reduces the resistance. So this resistance plus reduced resistance. Now, when this circuit is open, it has identical resistance. The total resistance is now more. So, the total current in this combination is less than the total current here. They will be equally bright, I agree, but less than the C that we considered before. So now here you have to think wisely. Here R equivalent is more now. Let me give you example. I know I can see your face. I can understand. Just give me 1 second. R equivalent is more, less than, less current than previous. So they will be equally bright, but dimmer than RC, dimmer than C in previous circuit. C in previous circuit. Look at here. I shall give you the example. For this one, for example, this is 100 ohm, 100 ohm, 100 ohm. Okay. What is equivalent resistance of parallel? 50. You studied in the previous first example. 100 parallel give you 50. So total resistance in circuit will be now 150. So in circuit A, R equivalent is 150 ohm. And in circuit B, 100 plus 100, R equivalent is 200. Now you can see in this circuit, when parallel 100 give you 50. 50 plus 100, 150. Here 100 plus 100, 200. More resistance, less current. Less resistance, more current. So here the current was more in first C circuit, and here current is less and equal from there. So this is what you need to understand. I think you understood it well. Thank you so much. And now you can stop the recording, and bye bye. And I will send you this one.